Hello everyone, am I audible? Yes. Okay. So we left at continuity in the last class, right? And today we'll be starting with differentiability. Differentiability as well as differentiation, right? So we have some formulae. We talked in the last class also about this, that there are some basic formulae of differentiation. Then we can discuss about differentiability also. But first, I would like to talk about how how did we form these formulae, right? कैसे हमारे पास ये सारे फॉर्मूले बने, what is the core method to form these formulae, right? And during that we will also understand this concept differentiability, right? So let's start with this. Okay, so let's start with differentiability. What is the meaning of differentiability? First, let's understand the physical significance of differentiability, and then we will understand the mathematical significance. Okay. So when we talk about physical significance, so let's say you have a curve. Well, guys, please tell me whenever I am not audible. Okay, I'll repeat myself. So for the physical significance, I would like to start with this. Consider a graph. Let's say y is equals to fx. And let's say we have some graph. We have already talked about graphs, right? So graph is a very what graph is. I mean, when we see visuals, we can easily understand what is the concept behind those. And also graphical methods and graphs are very important when we talk about maths, right? So let's say we have this function y is equals to fx, and suppose this is the graph of y is equals to fx. We don't care about the shape of the graph right now. We only care about the concept. Okay. So let's say this is the graph of y is equals to fx. Now, if I use these words that fx is differentiable, what does that mean? So y is equals to fx is a function and it is differentiable. It means that we can draw a tangent on this graph. For example, this is a tangent of the graph. Right? We do know about tangents, right? We have studied about tangents in circles in class 10th. So a tangent is something which touches the curve at one point only. So right now this is a tangent and this was the graph of y is equals to fx. So if I'm saying that this function is differentiable, it only means that we can draw a tangent on this graph. So if you want to understand what is the meaning of differentiability or what is the meaning of differentiation, so in physical significance, in physical terms, we say that a tangent can be drawn on this graph, on this curve, right? But now the graph is endless, right? So where are we talking about drawing this tangent? Which is the point at which we are going to draw this tangent? there are multiple points there. In fact, there are infinite points on this graph. So when we say that, okay, let's consider this statement first. If I say y is equals to fx is differentiable at some point x is equals to a, right? Let's say this is the point x is equals to a, right? So it means that I'm saying that a tangent can be drawn on y is equals to fx at the point x is equals to a, right? It only means this. So while talking about physical significance, this is the meaning of differentiability. Differentiability directly relates to tangency, right? Now, if I talk about how do we know whether a tangent can be drawn on it or not? So let's say if the graph is given, we can easily identify whether a tangent can be drawn or not. But if the graph is not given, then how do we identify? Let's say I've given you this function y is equals to sine x and check its differentiability. At x is equals to pi by 2. Okay. So it means that we want to know whether a tangent can be drawn at this point on this graph. Okay. But right now we don't have its graph. So what we will do is we will have to identify certain mathematical methods. We will have to learn some mathematical equations, or let's say mathematical concept, to understand whether a tangent can be drawn on this or not, right? So for that, we need to understand two principles, or sorry, one principle of differentiation. This is known as first principle of differentiation. There is also a second principle, but that is not important. But the first principle of differentiation is very important because it tells you how do you identify if a given function is differentiable or not. So let's give me 1 minute. Okay, we'll start. So we need to know first principle of differentiation to further solve this, right? So let's discuss first principle of differentiation now. And some of you must know some of the formulae of differentiation, but today we will discuss how these formulae came into existence. Okay, like the differentiation of sin x is cos x, but how do we know it's cos x? Right? There must be some formula. There must be some method to understand that. Just give me a minute. Okay, so let's discuss first principle of differentiation now. So first principle of differentiation says that consider a function y is equals to fx. For that function, now if you want to check its differentiability, whether the given function is differentiable or not. So first of all, you don't check differentiability at everywhere. You check differentiability for a particular point. So that point can be x is equals to 2, x is equals to 3, or whatever that point is. But right now we'll be taking a general point, which can be x is equals to a, right? So if you want to check the differentiability, okay, so I'll not be writing differentiability every time. I'll just write DIFFN. Okay, so this will be a symbol for differentiation or differentiability, both. So we are, if you want to check the differentiability of y is equals to fx at x is equals to a, then what do we do? So we will check two things: right hand derivative, which we call RHD, and left hand derivative, which is left LHD. So we will find out these two things. If these two things are equal for the given function, then we say that the given function is differentiable at the given point. Right now, the given point is x is equals to a. And if they are not equal, then the function is non-differentiable, right? But if a function is differentiable, then we can only use one of them to find out the differentiation. Okay, we'll talk about that later on. Just first to understand what is the concept. So now how do we represent differentiation? To represent a differentiable function, so let's say a function is y is equals to fx. So what will be its differentiation? How will we represent that? There are 2-3 methods to represent the differentiation of y is equals to fx. I mean the representation of the differentiation. So either we can write f dash x. F dash x mane differentiation of fx, right? Or we can write out f1x. These are all same thing, mind you. Okay, so f dash x or f1x or d of fx divided by dx. These are all the representation of differentiation. Representation of differentiation, right? So this is how we represent a differentiation, given differentiation. Now, if you are finding out the differentiation at a particular point, you just replace x with that point. So let's say I want to find out the differentiation of y is equals to fx at x is equals to a. So instead of writing that f dash x, I will write f dash a. I will replace x with a because it means that you are finding out the differentiation at a particular point and you put that point in place of x. So right now I want to find out the differentiation of y is equals to fx at x is equals to a. So first of all, I'm telling you how do we find out the differentiation. We find out these two things and then compare them. If they are equal, then we say that the given function is differentiable. And whatever is the value of the, after solving right hand derivative and left hand derivative, if they are both equal, that is the value of differentiation. And if they are not equal, then we say that the given function is not differentiable. So for example, we are talking about y is equals to fx right now. And let's say we want to find out the differentiation at x is equals to a. Then what we will do is we will write it as f dash a. And what is the value of f dash a? The value of f dash a will be limit h tends to 0, right? F of a plus h minus fa divided by h. This is your right hand derivative. And you can also understand we have used right hand. That is why we are taking a plus h, right hand, right? We have talked about right hand limit and left hand limit. And right hand limit we used to know, we know that right hand limit is a positive and left hand limit is a negative. Similarly, we are using those things here. So right hand derivative will be f of a plus h, and left hand limit will be f dash a limit h tends to 0, f of a minus h minus fa divided by, okay, so in the denominator, we are basically writing the difference of both of these inputs. In the first case, the difference of a plus h and a was h. If you subtract a from a plus h, you will get h. Similarly, if you subtract a from a minus h, then you will get minus h this time. So this is your left-hand derivative through the rule of first principle of differentiation. And if both of these are equal, let's say this is 1. Okay, my bad, sorry. So let's say this is 1 and this is 2. Then if 1 is equals to 2, if 1 is equals to 2, it means given function is differentiable. Given function is differentiable. And if 1 is not equal to 2, non-differentiable. That is how we can proceed. Now, if you say that the differentiation of sin x is cos x, this formula, this particular principle of differentiation will tell you whether that is true or not. So let's find out one differentiation through this method. Then we will go to the direct formula part, because we don't need to check whether a function is differentiable or not. We just need to know, okay, that we will talk about later on, but let's form one formula. Okay, so let's find out the differentiation of, okay, you tell me, you take any function. Tell me a function for which you need to, you may know the formula for all the functions, but you can tell me any function and we will find out the differentiation of that function, formula for differentiation. We can take any trigonometric, logarithmic, exponential, algebraic, any function, whichever you want. You want x cube, you want sin x, cos x, tan x, e to the power x, log x, whatever you want. If you have any suggestion, anyone of them. Okay, Austin. Let's start with sin x. Austin has a suggestion for us, sin x. So let's start with sin x. We'll find out the differentiation of sin x. Now you know already that the differentiation of sin x is cos x, but we will prove this. using the right hand derivative and left hand derivative concept, that the differentiation of sin x is cos x. Just give me a minute. I did not have lunch today, so I'm also eating while we are. शाविस बड़ी जल्दी आ गया आज क्लास में. We were talking about differentiability. First of all, we understood what is the meaning, physical significance of differentiability. So when we say that a function y is equals to fx is differentiable at some point x is equals to a, it means that a tangent can be drawn on that curve at the given point. So let's say I'm saying that y is equals to fx is differentiable at x is equals to a. It means that we can draw this tangent at x is equals to a. We can draw a tangent on the curve at x is equals to a. So this is a visual representation of what we are saying. So differentiability or differentiation means is directly related to tangency, condition of tangency. Now we are so let's say if a graph is given, we can always identify whether a function is differentiable or not. For all the JE aspirants, remember this thing that okay, I'm writing it here. So there are two conditions. If you see a graph, right? If you see a graph and you are asked whether the given graph is differentiable at this point or not, then you will check two things. First, the graph must be continuous at that point. Okay. So the condition of non-differentiability, I'm only writing the conditions of non-differentiability through a graph, using a graph. So if a graph is discontinuous, first condition is this. If a graph is discontinuous, then it is non-differentiable. This is for sure. Then it is non-differentiable. But the converse is not true. Remember this thing, okay? If a graph is, if a graph is non-differentiable, then it does not mean that the graph has to be discontinuous. A continuous graph can also be non-differentiable. But what we are saying is, if the graph is discontinuous, then it is 100% sure, it is 100% true that the graph will be non-differentiable at that point. But if a graph is non-differentiable, then it does not mean that the graph has to be discontinuous. Now, the second condition is, if a graph has sharp edge, then it is said to be non-differentiable. So now remember, if a graph is non-differentiable, then it can have, the reason can be two things. Either the graph is discontinuous or the graph has sharp edge or point. Okay, I'll show you one example for this and one for this also. So let's say my graph is this. For this case, you can understand like this. So let's say my graph is like this. Okay, now the graph is discontinuous. You can easily identify that at this point. At this point, the graph is discontinuous, right? Now, how can we draw the tangent on this point? Okay, let's say we are drawing the tangent on this curve. Let's say this curve is 1 and this curve is 2. So right now we have two curves to represent our function. If I want to draw the graph at this breaking point, if I have to draw the tangent on this breaking point, then I can have two tangent. One is this. If I draw on first part, the tangent will be this. If I draw on second part, the tangent will be something like this. Because at the same point, there are two tangents drawn. So we don't have a single output. That is why we will say that the graph is non-differentiable, because we cannot draw a single tangent. If you are drawing more than one tangent, then that is also a problem, because you do not have a definite output, right? And in maths, we always try to achieve definite output. We always want to be sure. We don't, this is not chemistry that an intermediate can change a lot of steps. No, there is a definite output. If you have a definite input, then you have a definite output always, right? That is why we don't want to even go to infinity. In the condition of domain, we have discussed this, that we never want to create infinity. That is why we never want that our denominator is 0. So if a particular point or if a particular curve has two tangent at a single point, then that is also a problem. Two tangents. So no definite tangent. Hence, the graph is not differentiable. Now let's also talk about sharp edge. So we have discussed about the graph of modulus function before. While studying functions, we have discussed about modulus function, and we also know the graph of modulus function. This is in V shape. If you don't remember, I will like to revise you. The graph of modulus function is in V shape, right? Now, this is a sharp edge. Sharp edge meaning the graph is reflecting back. Graph turns suddenly. You can also, see. If a graph is turning like this, these are smooth edge. There is no sharp edge here because the graph is not turning suddenly. The graph is turning smoothly, right? But in this case, the graph is turning back from this point, x is equals to 0 at 90 degree. So this is basically reflecting back. This is just like the image formed by a plane mirror. We have discussed about this. You guys have studied this in class 10th physics, that if you draw the image from a plane mirror, then an incident ray comes, and then there goes a reflected ray, right? So this is the same concept. But if we see this curve, then at this point x is equals to 0, the graph is turning back suddenly. So this is basically forming a sharp edge. Now, what is the problem at sharp edges? Sharp edge also have two tangents. I mean, both of these lines are working like tangents at this point. If you draw a tangent at this point, then this line, x-axis is also a tangent, right? This is also a tangent at this point. This is also a tangent. And this is also a tangent. There are three tangents at this point. So this is why, yeah, Shaviz, please. Shaviz, when we talk about differentiability, it means that there must be a definite tangent on that point. If we cannot form a single tangent at a given point, then we say that the graph is not differentiable. So to check the differentiability using graph, we will have to check there must be a single tangent at the given point. If we don't have a single tangent, or if we have multiple tangents, then in those cases we say that the given graph is not differentiable. And this happens in two cases. One, when the graph is discontinuous, and the second, when graph has a sharp edge. Sharp edge माने मुड़ जाए कहीं से भी, सीधा मुड़ जाए, मतलब suddenly मुड़ रहा है graph. This is not smooth transition. Okay. You guys can ask me your problems if you have any. As you are not audible to me, you can write me on chat if you want to ask anything. So now you are also, this is the graph of y is equals to mod x, if you don't remember. So always remember this. Y is equals to mod x, the graph of modulus function, that is mod x, is not differentiable at x is equals to 0. But if you take any other point, I mean, other than x is equals to 0, the graph is always differentiable. But y is equals to mod x is not differentiable. Not differentiable at x is equals to 0. Always remember this. Because at x is equals to 0, the graph has sharp edge. But if you ask me, talk about x is equals to 1, x is equals to minus 1, x is equals to 100, the graph is differentiable. Okay, Chavez. So there are more than one tangents because see, this x-axis is also working like a tangent to this curve. X-axis is a tangent, right? Okay, see here. If a graph is like this is a tangent here. This is also a tangent here. This is also a tangent here. At this point, they all are touching the graph at this point only. X is equals to 0. So there are basically three tangents. In fact, there are more than three tangents. I'll show you how. There are infinite tangents at this point. Okay, this is also a tangent. This. Okay, see from here. This is also a tangent. This is also a tangent. There are multiple tangents at x is equals to 0 in the case of y is equals to mod x. Did you understand this? I mean, you can easily form these tangents. Just form a line. So using the graph, there are two conditions. Now, mathematical approaches to find out a right-hand derivative and left-hand derivative to understand whether a given function is differentiable or not. Let's go to that. So I'm writing a question first to make you understand the concept of differentiability. So find the differentiation of so at a particular I mean, we can do both things. First is that we can find out the differentiation of any function at a general point also, and at a given point, at a particular point also. Right now, I just want to find out the differentiation of sin x. Okay, not at any particular point, but in general. So when I want to find out, sorry. When I want to find out the general differentiation, in place of a, I will be using x. So I'll use x plus f of x plus h minus fx divided by h, and f of x minus h minus fx divided by minus h, right? So, and if I want to put a particular point, then I'll replace x with that particular point. Okay. But right now, what I want to do is I want to check whether the differentiation of sin x is cos x or not. I mean, we already know that the differentiation of sin x is cos x, but how do we get that formula? Or can we verify that formula? We can think in both ways. So we will discuss about the differentiability of y is equals to sin x using the first principle of differentiation. Because all the formulae, whatever formulae we have, all the formulae are formed using this first principle of differentiation only. So use first principle of differentiation. Chavez, please ask me whatever you want to ask. First, I will take RHD, right-hand derivative. So if I want to find out right-hand derivative for y is equals to sin x, then we know what is right-hand derivative. Consider fx is equals to sin x, right? Now, according to right-hand derivative, f dash x is limit h tends to 0, f of x plus h minus f of x divided by the difference of x plus h and x, which is h. So, sorry, we should start from here. So, f dash x would be limit h tends to 0, f of x plus h. Now, fx is sin x, right? So if I want to find out f of x plus h, that should be sine of x plus h minus fx, which is sine x divided by h, right? Do someone of you remember sine a minus sine b formula? We have studied sine a minus sine b. Sine a minus sine b. Yeah, Chavez, please. What is sine a minus sine b? Oh. Okay, guys, please, everybody, take out a center page. Everybody, please take out a center page. Till then, I'll finish my chai. Everybody take out a center page, because after this point, there will be a lot of formulae used from differentiation as well as trigonometry. And I would like every one of you to remember these formulae, but I know that is difficult. So that is why you have to you have to write all the formulae on a center page. So take a center page outside and start writing the sum of the formulae. Let's first start with sine a minus sine b. I mean, we do have a lot of formulae, but मतलब sections बना लो यार ऐसे ना कि form some sections, like एक जगह सारे trigonometry के फॉर्मूले होंगे, फिर एक जगह सारे डिफरेंशिएशन के फॉर्मूले होंगे, फिर एक जगह सारे इंटीग्रेशन के फॉर्मूले होंगे. So you make these center pages and write down all these formulae on them. क्योंकि मैं पूछता रहूंगा अभी ना. See, what happens is in differentiation and integration there will be a lot of formulae used, and I'll keep asking you these formulae बार बार. I'll keep asking you again and again. Okay. I know you won't be able to answer those. I mean, if you don't have these formulae with you. तो इसलिए सबको अपने साथ ही रखना है सेंटर पे, जिससे कि इजीली आप उनके आंसर भी करते रहो और ऐसे ही आंसर करते करते याद होंगे भी। ऐसे नहीं होंगे कि आप एक दिन बैठे लेके और आपने सारे रट्टा मार लिया और फिर अब नेक्स्ट डे फिर भूल जाओगे। I mean, this is the only method by which you can remember these formulae. So please do this. Okay. So sin A minus sin B is 2 cos A plus B by 2 into cos A minus B by 2. This is the formula for sin A minus sin B. So if I want to solve this, I will have to apply this formula, sin A minus sin B. On this. So this will become, right now the angle A is x plus h and angle B is x. This is A, this is B. So this is sin A minus sin B. This should become 2 cos A plus B by 2. A plus B mane 2x plus h. We are just adding x plus h and x. So this will become 2x plus h by 2, right? Into cos A minus B by 2, right? Just a minute. No. This is not 2 cos A plus B. No, this should be sine, right? Yeah, Madhya, correct. Good. This should be sine of A minus B by 2. My bad. This should be sine of A minus B by 2. See, even, I mean, I do know how to create these formulae. मेरे को तो आता है कि ये क्रिएट कैसे करते हैं, तो मैं कर सकता हूँ कभी भी, बट आइदर यू शुड नो हाउ टू क्रिएट देम, बट इवन आई कैन फॉरगेट दिस। तो इसलिए ही बोल रहा हूँ कि इनको लिख के रखो हर जगह, वरना भूल जाओगे। दिस इज वेरी नेचुरल। इतने सारे फॉर्मूले हैं यार मैथ्स में। अराउंड वी हैव लाइक अराउंड, अगर हम जेई की बात करें तो अराउंड हमारे पास 1,500 से 2,000 फॉर्मूले होते हैं, 1,000 1,500 to 22,000 पर सब्जेक्ट। मैथ्स का बात कर रहा हूँ, ये तो मैं, इससे ज्यादा ही हो सकते हैं, कम तो नहीं है। तो इसलिए भूल जाओगे, भूलना तो बहुत ही नेचुरल है। सो हाउ टू, I mean, how to cure that? There's only one thing, that you can write these formulae and just go on and on and on and on. Whenever you want these formulae, just revise all of them. So this is sine of A minus B by 2. Sine of A minus B mane x plus h minus x, which should be h. So if you subtract x from x plus h, you get h by 2, right? Divided by h. You can further simplify this as limit h tends to 0, and this you can write as cos of, divide everything by 2. So this is x, 2x by 2 is x plus h by 2 into sine of h by 2 divided by h, and there is a 2 here, right? So if I take this 2 into denominator, so this becomes h by 2, right? We can also write it like this. I mean, this 2 will only go to numerator part. Now, why am I writing it like this? Because we do know a formula for limits. We have written this formula in while we were solving the last topic, continuity, that limit x tends to 0, sin x upon x is 1, right? Now, if you put h0 directly, what happens? हमने बात की थी कि अगर हमें लिमिट सॉल्व करनी है तो सबसे पहले आप h को डायरेक्टली पुट करके देख लो, है ना? You put your h directly and check what is the answer coming. So when I put this h directly, this is cos x, because this becomes 0 by 2, which is 0. So this becomes cos x. This becomes sine 0, right? Sine 0 is 0. And this denominator also becomes 0. So this all of this form becomes 0 by 0. If you put h0 directly, then you get 0 by 0 form. 0 by 0. You can see that yourself. 0 by 0 form, which is indeterminate form. And we have discussed, when we face an indeterminate form, what do? We use some formula to solve them. And right now we have trigonometric functions with us. So we will be using trigonometric functions to solve this. So this is a formula, because whatever is inside sine, the exact thing is in denominator. And this says the same, sine of x divided by x. So it is sine of h by 2 divided by h by 2. Now this whole thing becomes 1 if you apply limit h tends to 0 here. Okay, and this thing, if you put h is equals to 0 here, then this thing becomes cos x. So this is nothing but, you can rewrite this expression. Sorry.
Yeah, there is cos x, right?
Yeah, only cos x left. So if we rewrite this expression, we can have cos of x. We can write this cos of x outside, because we are putting h is equals to 0. This becomes 0. This only left, this cos of x plus h by 2 becomes cos x. And then this part, limit h tends to 0, sine of h by 2 divided by h by 2 becomes a formula, the value of which is 1. So this is cos x into 1, basically. So the right-hand derivative of sine x comes cos x. This is our first equation. Now we will go to left-hand derivative. First, we will write out the formula for left-hand derivative. Left-hand derivative can be calculated as f dash x is equals to limit h tends to 0, f of x minus h minus fx divided by minus h. We will use our given function in place of fx. So f dash x will become limit h tends to 0. We know our function is sine x. So fx is sine x. That means f of x minus h will become sine of x minus h minus sine x divided by minus h. This is again sine of a minus b formula. We will apply the formula again. Limit h tends to 0. This is sine a minus sine b, which becomes twice of cos a plus b by 2, right? A plus b by 2, and sine a minus b by 2. So this becomes 2x minus h by 2 if I add both of them, and then sine of minus h by 2 if I subtract them, divided by minus h. Now you know the formula, you know the procedure. We will simply solve this just like we have solved the first part. This becomes limit h tends to 0. This 2 from denominator will come to this 2 from numerator will come to denominator, and this can be solved further. So this will be written as cos of x minus h by 2. This becomes sine of minus h by 2. We have 2 in the numerator and we have minus h in the denominator. That numerator wala 2 can come to denominator like this. Now this whole part is 1. You can check that for yourself. This whole part is 1. And if you put h is equals to 0 here, you get cos x, right? So the left-hand derivative is again cos x. No? And you can simply understand from here that your first equation and second equation both are giving you the same thing. From first and second, we conclude that f dash x is cos x, which can further be rewritten as d of sine x, differentiation of the function with respect to x. This is written, this is read as differentiation of sine x with respect to x is equal to cos x. So that is how we got the formula for differentiation of sine x. This is the method to check. So if someone asks you that whether this function is differentiable at this point or not, what you do? You find out RHD, you find out LHD, and then you tell the answer. If both are coming out same, then the given function is differentiable. If the value of both of them are different, then the given function is not differentiable. Now, we will not repeat this procedure for every function. I just wanted to show you this for one function. What do we have? We have to remember some of the formulae which we have created based on the same concept, right-hand derivative and left-hand derivative. But we will be using this formulae directly for our further calculations. So the first question that can be formed from differentiability is that they can give you a function and a point, and then they will ask you whether this function is differentiable at this point or not. What you will do is you will find out the right-hand derivative, you will find out the left-hand derivative, and you will compare them. If both are equal, then the given function is differentiable. If both are not equal, if they are different, then the given function is non-differentiable. First type of function, which has a low probability, by the way, but first type of question from this can be based on differentiability, which is also a method to find out the differentiation of different functions.
Sir.
Yeah, Chavez. Was he on mute? Yeah, Chavez, you wanted to ask something? Okay, in that case, please. Anyone, please feel free to ask any doubt if you have.
Sir, like we have to differentiate these functions. So when do we know that we have to find RHD and differentiate?
Yes. To check the differentiability, we will have to find right-hand derivative and left-hand derivative. But it
No, sir, like in every case.
Yeah. क्या पूछ रहे हैं फिर से पूछ?
No, sir, like in some cases you have to directly differentiate, right? They ask
Yeah,
you to find derivative of this function.
No. If they ask you to differentiate something, then you use your formulae. But if they ask you to check whether a given function is differentiable or not, then you use this concept of right-hand derivative and left-hand derivative. मतलब कुछ जगह तो सिर्फ डायरेक्टली बोलेंगे कि डिफरेंशिएशन बताओ. अगर डिफरेंशिएशन पूछ रहा है तब तो हम we will use our formula directly. In most of the cases, the question will be like this. They will ask you to find out the differentiation only. Most of the questions we will be solving in this chapter are like that only. जहां पे हमसे क्वेश्चन पूछा जाएगा, आप कहेंगे डिफरेंशिएशन बताओ. हम अपने फॉर्मूले यूज करेंगे, अपने मेथड्स यूज करेंगे, जो भी हम आगे चल के पढ़ेंगे. अभी तक तो हमने पढ़े भी नहीं है. हम वो सब यूज करेंगे और बताएंगे कि हाँ जी इसका डिफरेंशिएशन ये है, बट देयर इज वन मोर वेराइटी when they will ask you whether a given function is even differentiable or not. फॉर्मूला तो बाद की बात है, आप ये बताओ कि डिफरेंशिएबल होगा कि नहीं होगा. So if they ask you whether a given function is differentiable or check the differentiability, they can also use this sentence. Check the differentiability of y is equals to something at something. They'll give you a function and they will give you a point and then they will ask you to check the differentiability. So in all such kind of questions, you will be checking RHD and LHD, but most of the questions will be based on के भाई differentiation बताओ, find out the differentiation for this or differentiate this. तो उसमें तो हम अपने फॉर्मूले और मेथड्स डायरेक्टली यूज कर सकते हैं, बट अभी तो हम बिल्कुल बेसिक से स्टार्ट कर रहे हैं. तो सबसे पहले तो हमें ये पता होना चाहिए कि डिफरेंशिएबिलिटी का मतलब क्या था और डिफरेंशिएबल कब बोलते हैं किसी फंक्शन को. डिफरेंशिएबल माने if you are saying that a given function is differentiable, then it means if you find out right hand derivative and left hand derivative of that function, then they should come equal. But हाँ, there will be a low probability of coming out a question on this concept. मतलब पूछा तो नहीं जाता यार कभी. आपके क्लास में अलग से पूछ सकते हैं, ऐसे स्कूल में पूछ सकते हैं, बट बोर्ड्स में तो नहीं पूछा गया कभी, बहुत ही कम. पहले पूछा जाता था, मेरे टाइम पे ये कॉन्सेप्ट था हमारे सिलेबस में, बट अभी नहीं है. और वैसे भी मुझे लगता नहीं कि 12th का में कॉन्सेप्ट होना चाहिए, ये 11th में कॉन्सेप्ट होना चाहिए एक्चुअली. थोड़ा सा तो हिला हुआ है हमारा एजुकेशन सिस्टम, बहुत ज्यादा तो नहीं मैं बोलूंगा, बट थोड़ी थोड़ी प्रॉब्लम्स तो है. जैसे दिस शुड बी अ क्वेश्चन फ्रॉम क्लास 11th to check out whether a given function is differentiable or not. But anyway, I mean, most probably we won't be having a question on this, but you should know how to find this out. Now, with the help of this first principle of differentiation or right hand derivative and left hand derivative, we have created a lot of formulae. So we will be using these formulae directly. So let's start with formulae of differentiation. Before we proceed further, I would also like to tell you one more interpretation of differentiation. We have talked about like what do we mean by differentiation. So I told you that the meaning of differentiation is the condition of tangency, whether we can form a tangent or not. The same thing, I mean the condition of tangency, can also be interpreted like this. Okay. So if I'm saying that a given function is differentiable at some point, it means that I can find out the change in y with respect to change in x. Okay. So first of all, I would like to tell you this. What is the meaning of dy by dx? What is the meaning of d? Again, there is a different interpretation. I mean, this is not a different interpretation. This is the same interpretation. Condition of tangency बोल दूं या ये interpretation बोलूं, both are same. Okay. So if I'm writing dy by dx, so what does this d means here? D of y with respect to d of x. This d means differentiation, right? We know that. This d means differentiation. But what is the exact meaning of differentiation? Change. You can also see it like this. Change in y, we are basically measuring change in y with respect to change in x, change in y with respect to change in x. And that is exactly the condition of tangent. I mean, the slope of tangent is the same thing, change in y with respect to change in x. स्लोप भी ऐसे ही निकाला जाता है यार. स्लोप का मतलब या डिफरेंशिएशन का मतलब, we want to know how our output is changing with respect to changing the input. So let's say एक और बहुत अच्छा एग्जांपल देता हूं मैं तुम्हें, ठीक है? And this will also clear out a formula here. So let's say, I mean, the first formula in this case is, if we are differentiating any constant, so this k represents a constant. So if you want to differentiate a constant, the differentiation of a constant is always 0. I'll also show you the examples here. So if I say that your function is y is equals to 4, find dy by dx. Right? Now y is equals to 4 is a constant function. So if I am finding out dy by dx, it basically means d of, in place of y you can replace with 4, d of 4 with respect to dx. Now this is basically constant. 4 is a constant. So the differentiation of constant is always 0. Some of you may know this, okay? But I would like to, I mean, I would like to explain why is this 0 with the same interpretation which we have discussed just above. So we are basically, if we are finding out the differentiation, we are basically finding out the change in y or the change in output with respect to change in input. If a function is constant, it means that if you change your input, there is no impact on output. Y is equals to 4 में आप x को कुछ भी रखो, you put anything in place of x, there is no change in y is equals to 4. Okay, consider these two functions. Consider these two functions. A function is y is equals to 4. In place of y is equals to 4, you can also write fx. Right? Both are same thing. Either you write y or you write fx, both are same thing, right? So fx is equals to 4. Now, if I say find out f0, so you replace x with 0, and the answer is same, 4. If I say find f1, the answer is same, 4. Right? इसमें तो कोई confusion वाली बात ही नहीं है. f0 भी 4 है, and the value of f1 is also 4. Let's consider one more function, gx. Okay, and let's say gx is 4x. Come again. What is the value of z0? G0. Can you tell me what is G0? It's 0, right? Now what is the value of G1? 4. Now you see, you have increased your input by 1. You have increased your input from 0 to 1, and your output gets increased by 0 to 4. So if you see change in output divided by change in input, for the first function, पहले output था 4, बाद में भी था 4. पहले input था 0, बाद में input था 1. Right? Again, in the second case, first output was 0, second output was 4. So the change in output is this, and change in input is this. What's the value? This comes out 4 here. What's the value here? This comes out 0 here. Even if you find f2, that is also 4. f3, 4. f4, 4. f1 lakh, 4. So the change in output is 0, in case of constant. While change in output will take some value if the function is not constant. It can take any value. We have only discussed the example of gx is equals to 4x, but we could have taken a lot of other equations as well, right? And in those cases, there may be different change, but there will be some change, right? So when I say that find out the value of differentiation, we mean that we want to find out the change in y with respect to change in x. Have you changed? Right, so change in y with respect to change in x. So in case of constant, we do not have a change in output because the output is always constant. That is why the differentiation of all the constants is 0. Okay, this is our first formula. Differentiation of any constant is 0. Then second formula, differentiation of an algebraic function. And by algebraic, we mean x to the power n, where n is anything other than 0. If n is 0, then we have a constant, right? Then this can be expressed as n into x to the power n. Where n is not equal to 0. For example, I would like to show you the use case. So this is fx is equals to x cubed, right? Let's say we want to differentiate this. Fx is equals to x cubed. How do we do that? We will first see what kind of a function is this. We can observe that this function is algebraic. Okay, how do we identify a given function is algebraic? Austin, do you know this? Can you identify this is an algebraic function or not?
Not sure, sir.
Okay. तो ठीक है यार, मैं तुम सब लोगों को बताना चाहता हूँ कि देखो, अगर हम algebraic function जानना चाहते हैं ना, तो algebraic function और exponential function, there is a very basic difference between them. Algebraic function होते हैं variable to the power constant. Like this, x cube, x to the power 7, y to the power 10. There can be any variable and its power will always be a constant. When we say exponential function, the roles are reversed. Now, constant to the power variable. I'll also write here some examples. See, x to the power 7, y to the power 8, x to the power minus half. All are type of variable to the power constant. While this is the type of 2 to the power x, 2 to the power sine x, 3 to the power y, or 3 to the power y square. Now this y square in itself is a variable, right? So all the kind of functions where variable to the power constant is involved are known as algebraic, while all the functions kind of constant to the power variable are exponential. तो मैंने यहाँ पे देखा fx is equals to x cube दिया हुआ है. X cube is a algebraic function. How do I solve it? I'll take the power outside. The power given is 3. So I'll take the power outside and will reduce the power by 1. So f dash x is equals to 3x square. So let's say I have fx is equals to x to the power 100. Can you guys tell me what will be the value for f dash x? ऐसे बोल के ही बता दो यार. You don't need to write. Just tell me. Speak. If fx is equals to x to the power 100, then what is f dash x? What is the differentiation of this?
100x raised to 99.
100 into x to the power 99. We will take the power outside and will reduce the power by 1. तो अगर x की पावर 100 था तो मैं 100 को नीचे लेके आऊंगा और 100 से 1 माइनस कर दूंगा, विच इज 99। अगेन 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 वन, सॉरी, sorry for the disturbance. I think there was an anomaly in our house. So sister is okay. So let's start with this. Yeah. Let's say we have this function fx is equals to x to the power minus 2. Then what will be our f dash x? This is also an algebraic function, right? X to the power minus 2. कोई भी बता सकता है, anyone? So we will take the power outside. हम पावर को बाहर निकालेंगे और एक पावर घटा के लिख देंगे. We'll reduce the power by 1. So सबसे पहले हाँ, yeah, please, anyone? नो थरीफ, -2 तो बाहर आएगा, सही बात है, पर x की पावर क्या होगी? -2 -1, एक पावर रिड्यूस करेंगे ना. एक पावर रिड्यूस करने का मतलब है जो भी पावर दी गई है उसमें से -1 कर दो, है ना. सो दिस विल बी -2 इंटू एक्स की पावर -3. नो, क्यों जी, बता दो जरा ये बात. समझ आई हुमामुद्दीन? ये बात समझ आई कैसे कर रहे हैं?
जी सर।
चल फिर ये करके देख, ये बड़ा इंपॉर्टेंट है, ये दोनों बड़े इंपॉर्टेंट है, यूज होंगे बार बार. एक एक्स की पावर हाफ वाला और एक एक्स की पावर माइनस हाफ वाला, मतलब ये रूट है ना, हाफ का मतलब होता है पावर रूट. सो दीज टू विल बी यूज्ड क्वाइट फ्रीक्वेंटली, बट बिफोर दैट जस्ट सॉल्व दीज. पहले आप सॉल्व करके देखो, बाद में जब हम इसको यूज कर रहे होंगे तब की बात हम तब करेंगे. नो शावेज, हाँ तारीफ अभी करेक्ट है, ये पहले वाले का आंसर तो करेक्ट है. अब ये वाला दे, सॉल्व दिस वन. एक्स का पावर -12, एक इसको सॉल्व करो और फिर एक्स का पावर हाफ इसको सॉल्व करना. तो पावर तो नीचे लेके आना ही है, तो -12 तो नीचे आ जाएगा पूरा. अब एक्स की पावर में जो भी यहाँ पे दिया गया है इसमें से -1 कर दो, कितना आया? कैन एनी वन ऑफ यू सॉल्व दिस? नो, इट्स द टफेस्ट क्वेश्चन इन द वर्ल्ड. भाई ये तो अच्छे अच्छे लोगों से सॉल्व नहीं हुआ. फायजा, वेरी गुड, you're doing really good. Solve the next one also. क्या होगा शावेज?
-1/2 into x raised to -3/2.
भाई -12 में से माइनस करेंगे 1 तो -3/2 बनेगा. ये मैं अब इतनी मैथ्स नहीं दिखाने वाला हूँ मैं, सॉरी. ये मैं एक्सपेक्ट करना कि मैं तुम्हें ये सॉल्व करके दिखाने वाला हूँ. चलो नेक्स्ट वाला करो फटाफट. ओके, आई गॉट सम आंसर्स. शरीफ, फायजा, रियली प्राउड ऑफ यू बच्चा. नो, दिस टाइम आई एम स्टिल प्राउड ऑफ यू, बट यू हैव गिवन द रॉन्ग आंसर दिस टाइम. गोइंग गुड, बट शरीफ गलत है. कोई -12 -1 करेंगे तो -3/2 आ रहा है ना भाई. इसको सॉल्व करके देखो, सॉल्व करोगे इसको -3/2 आएगा. हाँ ये भी मत करो सॉल्व, है ना, 5th क्लास का बच्चा सॉल्व कर सकता है ये. हमारे यहाँ तो 4th 5th में पढ़ा दिया जाता है। सब्ट्रैक्शन ऑफ फ्रैक्शन। हाँ गुड शाविज, करेक्ट है यार, इसका बहुत यूज आने वाला है। तो x की पावर हाफ का क्या मतलब है? रूट एक्स। मरिया गुड। x की पावर हाफ का मतलब है रूट एक्स, तो बेसिकली यू आर फाइंडिंग आउट द डिफरेंशिएशन ऑफ रूट एक्स। और अब आपने रूट एक्स का डिफरेंशिएशन फाइंड आउट अगर सही किया, I don't know but if you solved it right, then it must come like this. Okay, and this can be written, think about it, this is x to the power minus half, so I can write it as, now it is good, correct. So x to the power minus half, कैसे लिखोगे x to the power minus half? You can write it like this, x to the power half, 1 upon x to the power half, and 1 upon x to the power half माने क्या? 1 by root x. तो भाई इसको याद कर लो सभी लोग, प्लीज रिमेंबर दिस, the differentiation of root x is 1 upon root x, sorry 1 upon 2 root x. This, there is also a 2, right? Please remember this again, the differentiation of root x is 1 upon 2 root x. The differentiation of root is 1 upon 2 root. The differentiation of root is 1 upon 2 root inside same thing. अगर आप x की पावर हाफ का निकाल रहे हैं, if you are finding out the differentiation of root x, then it will be 1 upon 2 root x. बहुत ज्यादा यूज होने वाला है, we'll be using this very frequently. ठीक है जी, there are 2 formulae now. Okay, then the third one, अभी हमने सीख लिया algebraic का. Now let's understand the differentiation of what? Exponential. This is exponential. So what is the differentiation of exponential function? A to the power x log a, where what is a? Greater than 0. A must be greater than 0. We cannot find out the differentiation of minus 2 की power x. Minus 2 की power x तो कभी देखने को मिलेगा ही नहीं. You will never see minus 2 to the power x, because in exponential function this constant must be positive. This constant must be positive. This constant must be positive. Okay, but the differentiation of exponential function is a to the power x log a, and the same use is in this e to the power x. This is e to the power x, where e, what is e? E is Euler's number. Euler was a mathematician. काफी काम किया भाई इन्होंने मैथमेटिक्स में. तो Euler was a mathematician. उन्हीं के नाम पे there is a number which is known as Euler number and denoted by e. Okay, it's an irrational number. It's an irrational number, and its value is around 2.718. So e, I'll tell you some facts about it. This is an irrational number, also known as Euler number, and e is equals to 2.718. You don't need to remember the exact value, okay, but you must remember that its value is around 2.7. ऐसे याद रखना हमेशा. Okay, you will use e in the later term, I mean in the later classes also and in the later chapters also, but you should know what is e. Okay, now let's also understand the application of these. So for example, we are given that fx is equals to 2 to the power x, then f dash x will be what? 2 to the power x log 2. Similarly, हमें बोला गया fx है 3 to the power x, then what is f dash x? 3 to the power x log 3. This is how we apply this. Again, fifth, logarithmic function का differentiation. The differentiation of logarithmic function, log x. Okay, when I write log x, it means okay, I don't like to misguide you guys. Okay, so I'll write it like this. This is ln. I'll tell you what is the difference between ln and log. Some of you may know, but we will discuss this. So if I am differentiating ln x, what do we mean by ln x? Ln x means natural logarithm. Okay, then the differentiation is 1 upon x. First, but before this, first understand, if I'm writing like this, log x, so here log na, whenever we write log, there are two components of log. Log a to the base b. This is known as input of logarithm. And this b is known as base of logarithm. Okay. Like in case, if I write log 3 base 2, it means the input is 3 here and base is 2 here. Okay. There are two things associated with the log. Now, if I write log x, just simply log x. So I'm not writing the base here. It means that the base is assumed to be 10. But if I'm writing like this ln x, it means that the base is e now. So instead of, in all other cases, the base will be shown. But in these two cases, they will not show you the base. They will just write the expression directly. So if they are writing log x, it means that the base is 10. If they are writing ln x, it means the base is e. In all other cases, they will specifically show you what is the base. Like if they want the base 7, they will write it log x to the base 7. Okay, but in these two cases, you will have to remember you will have to remember this, and you will have to decode this yourself, that if they're writing log x, it means the base is 10. If they are writing ln x, it means the base is e. Now in calculus, all the calculation will be in base e. The base e is very important here. Okay, so we can only differentiate a logarithm. Remember this, okay? Please pay attention. We can only differentiate a log whose base is e. If the base of the log is not e, we will have to change the base to e. Now, how do we do that? We will understand that, because we will be having logarithmic differentiation as a topic in this chapter. So we will understand about logarithm there. अभी मैं उतना बात नहीं कर रहा logarithm के बारे में, हम बाद में बात करेंगे जब हमारे पास ये चैप्टर आएगा. हमारे पास पूरा एक एक्सरसाइज है which is based on logarithmic differentiation only. Okay, but right now I'm just telling you the basic formula, very basic formula, how to differentiate a logarithmic function. To differentiate a logarithmic function, ln x, the differentiation of ln x